Okay, you guys, so what we're doing is we're looking at 7.2 still. Remember we were looking at the standard form of the x. Sorry, this is bothering me. We're looking at the standard form of the quadratic equation. So the one that says x squared x in a number. And we're looking at how can we solve for the x-intercepts, okay? Because when you put y in as 0, you get 0 equals x squared x in a number, right? So we're looking at ways we could solve. The first way we kind of looked at was the quadratic equation, right? Because we actually tried to factor this one example I gave us, and we ended up couldn't figuring out what times what equals the end number and adds to the middle number. We couldn't figure it out, so we actually plugged it into the quadratic equation and factored it, and it ended up being 3 plus or minus root 14. So obviously there was a reason why we couldn't figure out what times what would add to that stuff, right? Now, we continued on and looked at different ways of factoring. The difference of squares factoring, right? Very simple. You when you look at it, the first number has to be squared, or the first term has to be squared, and the last term has to be squared. There's only two terms in a difference of squares. You take the square root of the first one, put it in the front of two brackets, take the square root of the last one, put it in the back of two brackets, and then you put a plus or minus sign in between. Because if we were to multiply this back out, we get x squared plus 3x, x squared minus 3x plus 3x minus 9, right? And the negative 3x and the plus 3x would cancel each other out. The last thing we looked at was trinomial squares, right? And this was one that we finished off at the end of the bell, right? Trinomial square, how do you notice you have a trinomial square? You're able to take the square root of the first one, 3x. You're able to take the square root of the back one, 2. When you multiply them, 3 times 2 is 6. Oh, I think you had to double it. This might not be a trinomial square. That goes in the middle. And then what happens is you take the square root of the front, square root of the back, and you put the sign that's in the middle one, in the middle, and you put a square. So let's just double check that we actually had a trinomial square in the first place. How do you do that? 3x plus 2 times 3x plus 2, we FOIL, right? I don't know if I had a trinomial square to start with. So 3x times 3x is 9x squared, right? Do you guys remember FOIL? First, outside, inside, last, right? So the outside is 3x times 2, which is plus 6x. The inside is 3x plus 2, or times 2, which is plus 6x. And the outside, or the last, is 2 times 2, which is plus 4. So the trinomial square should say 9x squared plus 12x plus 4. So when I started, I was wrong. You have to double that middle thing. That should say 12x. Okay? So let's come up with one more trinomial square that I know what I'm talking about now. Okay? So, what's a perfect square? Like 16x squared. And what's another perfect square? 25y squared. And then, so 4x times 5y is 20xy. So double it will give me 40xy. So if I put negative 40xy, it would give you a question like this one, and it'll say, can you factor it? Can you solve for the x-intercepts? Right? To factor it, you've got to first look at it and go, this one might be a trinomial square. Take the square root of the first one, 4x. Take the square root of the back one, 5y. Multiply them together. 4 times 5 is 20 xy. And then double it will give me 40x. Yeah, this one's a trinomial square for sure. So what do you do with the trinomial square? Take the square root of the first, put it up front. Take the square root of the back, 5y. And what goes in the middle? The sign that's in the middle, so negative, and then we square this. Okay? If I wanted to know the x-intercept, what would I have to do? Set y to 0, right? So I'd set this whole thing to 0. Okay? So when I set this whole thing to 0, to solve for the intercepts, right, the x-intercepts, I get 4x minus 5y. I could put this whole square equals 0. Take the square root. What's the square root of 0, Luke? 0, right? So we get 0 equals 4x plus 5y. Here's my issue. When I did this whole trinomial square, I have an extra y in it, so I actually had to set that y to 0 as well, and then solve, right? But in most cases, you wouldn't have a y in your factored form, right? You just have x squared x in a number. Okay? So if we set this to 0, it'll give you 4x equals 0. Divide by 4, so x equals 0. So your point would be 0, 0. So if you put 0 in for y, you get 4x equals 0. Divide by 4 gives you 0. Okay, so you get that point. Those are trinomial squares. Those don't happen very often. Okay? This is a very special case. Same thing with difference of squares. The general factoring that you do, or that you'll come across with, will deal with something like this. X squared minus 5x plus 6. Okay. So this is a general factoring case, so you can either choose to think about it and go, okay, well, let's go through the equation, right? So going back, you could just use this equation, x is equal to negative b plus or minus the square root, right? And go through it that way. Or you could go through that factor way that you were taught in junior high, right? You go, what times what gives me 6 and adds to give me negative 5. So what multiplies to give me 6 and adds to give me negative 5? Negative 2 and negative 3. You guys agree? I agree. 2 negatives make a positive 6. And then negative 2 plus negative 3 gives me negative 5. What do we do with these values? Okay, you actually put them in the factors. Y is equal to x minus 2, x minus 3. That's factoring it. Now to solve for the x-intercepts, what do we do? Set y to 0. So we set each of them to 0. So we get x minus 2 equals 0, and x minus 3 equals 0. Because if you're solving for 0, 0 times anything is still 0. So if this becomes 0, y equals 0. Or if this becomes 0, y equals 0, right? So if we solve for these cases, we get x equals 2. And x equals 3. So the points for the x-intercepts are 2, 0, and 3, 0. Did you guys want to see this in the quadratic equation? No, yes. Okay, so I'll do one with the quadratic equation. He just wants less homework time. More homework time at home. Okay, so you need to know what A, B, and C is, right? What's A? In our original equation was 1. What's our B value? And our C value is positive 6. So our equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you guys, do you have to remember that? No, you don't have to be a keeper like Miss Bear. You're okay. I'll give you that formula, okay? So that formula is yours. Plug and chug is basically all you have to do. We get x is equal to negative and negative 5, so positive 5 plus or minus the square root of negative 5 squared. So that's 25 minus 4 times A, 4 times 1 is 4 times C is 6. 4 times 6 is 24, right? So minus 24 all divided by 2 times 1. This gives me x is equal to 5 plus or minus the square root of 1 all divided by 2. What's the square root of 1? 1. So this is like saying 5 plus 1 divided by 2, or 5 minus 1 divided by 2. What's 5 plus 1? 6. Divided by 2 is 3. 5 minus 1? 4. Divided by 2? 2. So in this case, we get x is equal to 3 or 2. And we should always put it into our points, 3, 0, and 2, 0, which is what we saw for prior. Okay? So that's the general factor. Good? Let's take a look at a different case. What if y is equal to 2x squared minus 2x, minus 4x plus 2? What would you do here, you guys? It's not a trinomial square. It's definitely not a difference of square because it has 3 terms. Oh, good. Someone's remembering from way back then. Common factors. Okay. If you didn't remember common factors, you could go into the quadratic equation, or you could go into decomp. Okay. So let's factor. Take out a common factor. What do you do with a common factor? You look for like terms. What's your like term all the way along? 2. So we'll get y is equal to 2 bracket x squared minus 2x plus 1. How can we continue to factor this? Well, we start looking at what times what will give us positive 1 and add to give us negative 2, right? Negative 1 and negative 1? Okay, good. Okay. Other people would have said, why are you jumping right into this? This is a trinomial square. Take a look at what's the square root of the first one? X. What's the square root of the last one? X times 1 is 1x double. It gives you 2x, right? So we could have jumped right into trinomial square root and come up with this, right? But let's do it this factor. There's like 5 different ways you could solve for these things, okay? So we were jumping into factoring, so we'd get y is equal to 2 bracket. So you get negative 1 and negative 1. We'll multiply to give you the positive 1 and add to give you negative 2. So I'll give you x minus 1 times x minus 1. Guys, guess what that is? That's x minus 1 squared. That's what we just wrote up prior to this, right? How do you solve for the x-intercepts? Well, you set y to 0. Well, can 2 ever equal 0? No, so that's not anything we deal with. X minus 1 equals 0. X minus 1 equals 0. Do I need to write it twice? Probably not, right? This is just one of those cases that the parabola only hits the x-intercept point. The vertex is on the x-intercept, is what it means. So this, whatever we solve for, is the vertex. So x is equal to positive 1, so that point is 1, 0. So that's the x-intercept of that case. Okay? Let's do one more type. What's the last type that I'm wanting to factor? Decomposition. Okay? I'm going to try and make up a decomp one on my head. We'll see. We'll see if we can do this. Let's do y is equal to 2x squared. but then we could take out a common factor if I did this. Okay? You could take out a common factor. Let's do decomp, okay? I know. I just can't think this morning. Let's do decomp on this. How do you figure out decomp? Do you guys remember decomposition? It's not that confusing, actually. To do decomposition, you multiply the first term and the last term. You multiply A and C. Okay? So you figure out what will multiply to give you 12 and add together to give you that middle one. 8. What multiplies to give you 12 and adds to give you 8? 6 and 2. Okay? This one's easy. Sometimes they're harder to figure out, but it's 6 and 2. What do we do with this 6 and 2 if it's a decomp type? If there's a value in front of the x squared, you put it in between. You break this 8x up into 6x plus 2x. Okay? And then I just carry the other stuff down. So I get 2x squared plus 6x plus 2x plus 6. Okay? Good. Then you bracket the first two and the last two. So I bracket the first two, I bracket the last two, I put a plus sign in between. Okay. Then we take out common factors from each. She's right. So what's the common factor out of this first one? 2x. So we're left with x plus 3. What's the common factor of the next one? Plus 2. So we're left with x plus 3. See, you have something common in each term. It's x plus 3. Ready? So if we take out the x plus 3, we're left with 2x plus 2. Okay? You could factor out a 2 from there now if you wanted to, and then you'd end up with 2 times x plus 3 times x plus 1. But it would have been okay if you would have stopped there and solved each bracketed thing for the x-intercept. Okay? This isn't our end though, right? This would be the end in grade 9 or maybe even in grade 10. But now we're looking for x-intercepts. So you factor, and then you set each factor to 0. Okay? So to look for x-intercepts, you factor, and then you set each factor to 0. So 0 equals 2, never. X plus 3 equals 0, at x equals negative 3, and x plus 1 equals 0 when x is equal to negative 1. Right? So our x-intercepts are negative 3, 0 and negative 1, 0. So can I tell you something? We really didn't learn much new. It's just trying to remember from way back into grade 9, right? Way back into grade 10. So I'm just trying to grasp onto your memory to remind you guys how to factor, right? And how to use that quadratic equation, because Mr. Thal taught you how to use that quadratic equation, right? Now, what are we going to do today? I want you guys to practice factoring, and I want you to practice, what else? Quadratic equations. Okay? So I've got 2 worksheets for you. They're not in your textbook. They're worksheets for you on solving x-intercepts. Okay?